the critical importance of phosphatidylserine for your health. Inside your body, there's a fascinating nutrient at work, especially within the command center, your brain. It's not one of those flashy antioxidants you see in every headline, and it isn't some newly discovered miracle molecule. It's a specialized fat, a phospholipid, that plays a critical role in how your brain cells talk to each other. It is a key player in your brain's orchestra and may even act as a shock absorber for your body's stress response. The interesting thing is, as we get older, our body's ability to make it can decline, which has led researchers to ask if this drop contributes to things like brain fog, memory lapses, and fatigue. We're talking about a powerful compound called phosphatidylserine, and getting to know it might be a genuinely smart step for your long-term health. What if I told you that the health of your brain cells could have a real impact on how sharp and focused you feel? Or that your ability to handle stress might be linked to a specific fatty substance that, while not the most abundant, plays an outsized role in brain function? This isn't science fiction. It's the reality of your biology. And today, we're pulling back the curtain on an important nutrient you've probably never heard of. We're going to look at the science and see how this one compound might hold a key to supporting brain functions like memory, and how it's being studied for everything from helping with ADHD symptoms to enhancing exercise recovery. The cellular gatekeeper. What is phosphatidylserine? So what exactly is phosphatidylserine, or PS as we'll call it? At its core, PS is a phospholipid, which is a specialized fat molecule with a phosphate group attached. Think of your cells as tiny, bustling cities. The cell membrane is like the city's border control, managing what goes in and out. Now, PS isn't the main building block of these walls. That honor goes to other phospholipids like phosphatidylcholine. Instead, PS is a more specialized, less common component, making up a smaller fraction, perhaps less than 10% of the total phospholipids in your body. But it has a very important job. It's an active gatekeeper, especially in the brain, where it's found in unusually high concentrations. Every nerve cell in your brain is wrapped in a membrane, and this membrane's job is to send and receive signals. PS is crucial for this process because it helps the membrane stay fluid and flexible. A flexible membrane allows receptors to move around, catch signals efficiently, and make sure nutrients get in while waste gets out. If a membrane loses this fluidity, communication can slow down. Nowhere is this more critical than in your brain. Your brain is about 60% fat, and the high concentration of PS in your neurons is no accident. Nerve cells need lightning-fast communication, and PS helps ensure the membranes are in prime condition to fire electrical signals, release neurotransmitters like dopamine, and form new connections, which is how we learn and form memories. Our bodies can make their own PS, but the process is complex and may become less efficient. Some of this research has shown that PS can support the density of these connections, which has led scientists to be hopeful about its neuroprotective effects. It's important to be clear. This has not been demonstrated in humans taking supplements, but it's a key reason why researchers are so interested in it. This potential has made PS a subject of research for neurodegenerative diseases like Alzheimer's. Early clinical trials using bovine-derived PS showed modest but encouraging improvements in cognitive function in patients with early-stage Alzheimer's. It's by no means a cure, but it seemed to provide a supportive environment for struggling neurons. However, a lot of that strong early evidence came from the now unavailable bovine source. Trials using plant-based soy PS have shown weaker or marginal benefits for those already diagnosed with dementia. This doesn't mean it's useless. It just refines our understanding of where it might be most effective, perhaps as a supportive nutrient in the very early stages of cognitive decline. As for other conditions like Parkinson's disease, the evidence is even more sparse and should be considered highly preliminary. Beyond the brain, PS for exercise and physical performance. While PS is famous for its brain benefits, it's also made its way into the world of athletics, which might seem strange at first. But it comes back to that same mechanism we talked about: stress and cortisol. Intense exercise is a major physical stressor. That stress is good. It's what makes you stronger, but it still triggers a surge of cortisol. Too much cortisol for too long can promote muscle breakdown, slow down recovery, and lead to overtraining. Because of its potential to buffer the cortisol response, some athletes use PS to try and shift their bodies from a breakdown state to a building state more quickly. So, does it work? The evidence is inconsistent. Some studies involving cyclists and runners, often using higher doses around 750–800 millimolars, found that PS did help reduce cortisol levels after intense training. Some participants in these studies also reported feeling less muscle soreness. One study even found that cyclists taking PS could ride at a high intensity for longer before getting exhausted. However, other well-designed studies, especially those using plant-based PS, have found no significant effects on cortisol, muscle soreness, or performance. So, the jury is still out. The potential benefit for athletes is likely twofold: a possible but not guaranteed physiological effect of managing cortisol, and a more reliable cognitive one. Sports require sharp focus and quick decisions. By supporting cognitive function under stress, PS can help an athlete stay mentally sharp even when physically exhausted.